2, 3. Can you all hear me? 1, 2, 3. 1, 2, 3. Can you hear me? If you can hear me, please type yes in the comments. That way I know that you guys are able to hear what I'm saying, and this will work out okay. Oh, we got a bunch of people on this morning. Hopefully you guys can all hear me okay. Good morning to Sarah and Braylon, age 5 in Bellevue, Iowa. Fantastic. Good morning to Krista and Aiden in Sturgeon Bay. And let's see here. Good morning to Dylan in Manitowoc. All right. Betty Van Aston's hoping some of her students are watching today. We got Ted in Manitowoc. Rosie Thiel is on there this morning. Oh, a whole bunch of you. Greg Mix is on from Manitowoc. We've got like half of Manitowoc watching this morning. All right, fantastic. Hey, how's it going, everybody? Good Monday morning. You know, it's kind of rare where people actually say good Monday morning. Usually Monday is like, it's Monday. But this weekend, I mean, it was just so awful weather-wise. The rain, the wind, just raw. And of course, everybody's stuck inside with the pandemic, the virus. So, you know, I'm just glad that we're getting a break from the rain. And also a little bit of inside baseball, if you will. When I get here, I have a lot to do, and I rarely have a chance to sit down and actually eat breakfast. So, like, from the time this popped up on Facebook and you saw the slate, the screen there, until now you see me on camera, I powered down a banana. Whoops, was most of it. So that was breakfast. Breakfast in 2 minutes. I haven't even had a chance to have my granola bar yet. So kids, if you're watching at home, it is important that you have a healthy, full breakfast before you do any schoolwork, either at home or at real school whenever that resumes. So anyway, good morning to all you folks out there. I want to say thank you for the great attendance for last week's weather school. We had so many people who checked in and learned about thunderstorms. Thunderstorms is such a broad topic. I mean, we could talk for hours about thunderstorms. So last week we covered some of the basics. And if you missed that and you want to watch that again or for the first time, if you go into my Facebook page and if you click on videos, they're broken down into sections. You should see under Weather School last week's lesson about thunderstorms. Just basic stuff about thunderstorms. Lasted about 45 minutes. And then I'll have this one posted in that Weather School section as well once we're done. Okay, so today we're focusing heavily on lightning and hail, phenomenon that is common with thunderstorms, especially lightning. But we're going to start off with hail first. You know, I think hail is an amazing thing. And the thing about hail is that it's happening in a thunderstorm where it's really, really chaotic and hectic. In fact, it's so chaotic and hectic, I got to back up and use the right clicker here. Okay, hail formation explained. So you remember last week, we were talking about thunderstorms, cumulonimbus clouds. And we were talking about how cumulonimbus clouds or thunderstorm clouds have updrafts and downdrafts. Now, updrafts are currents of warm air rising up into the thunderstorm cloud, allowing it to tower up in the sky. And the air goes up and it cools down, and eventually it begins to sink in a downdraft. A downdraft is a current of air sinking within a thunderstorm because cold air is heavy, it's dense, it has a tendency to come down. So hail, you know, starts off as really just a cluster of water droplets or supercooled water droplets that go up into the thunderstorm. Now, even during the summertime, when it's hot on the ground, you know, it's in the 80s or even the 90s, way up in the cumulonimbus cloud, temperatures are below freezing. I know it's kind of weird to think about that and when it's like, you know, June and July and August, but in the upstairs part of the cumulonimbus cloud, it's below freezing. So when water droplets go up into the cumulonimbus cloud, a thunderstorm cloud, they turn into little bits of ice. Little baby hailstones, if you will. So the updraft carries the water droplets up into the top of the cumulonimbus cloud, they freeze. Now, they don't always stay there. A lot of times they get carried back down in the thunderstorm in the downdraft. So the piece of ice comes down inside the cloud, and more water droplets stick to the piece of ice. And then it gets caught back in the updraft, and up it goes. So you have a cycle that repeats itself. Hail goes up, freezes, hail goes down, more water droplets stick to it, hail goes up, that layer of ice freezes up and down, up and down. So the hail is carried up and down inside the storm cloud, and hailstones will grow by colliding with some of these supercooled water droplets inside the cloud. So a little bit of homework for the future for you parents out there. Obviously today we don't have hail, but the next time we get a thunderstorm, and if we have some decent sized pieces of hail, once the storm is over and it's gone, go outside, collect a large hailstone, or as large as you can find, bring it inside, put it in the freezer. Then, obviously, kids, you're going to need your parents' supervision. But mom, dad, or whoever, with your child, take the hailstone and cut it in half. What you're going to see inside the hailstone that's cut in half are rings, kind of like a cross-section of a tree. You're going to find rings inside a hailstone that's broken into half. Each ring is a trip up and down inside a thunderstorm, a cumulonimbus cloud. Now think about this. So most thunderstorms are about 6 to 10 miles straight up in the sky. So how many miles is that hailstone traveling before the hailstone gets so heavy that it falls? Once the hailstone gets big enough where the updraft can't keep it up in the sky, it crashes down to earth. That's a lot of miles for a piece of ice to travel before it ends up in your backyard. I mean, in my opinion, I always find that just absolutely amazing. All right, so let me see here if I can look at some of the... Does anybody have any good questions here? All right. Melanie says, hail is cool until it breaks your windows. I remember when I used to do storm chasing in college, we would travel out towards western Kansas, the Oklahoma and Texas panhandles. It was common to see billboards that were from, auto repair places saying, hail damage, come to our body shop. Happened all the time out there. You see that a lot also in Colorado and Wyoming. It's a little bit of a colder climate compared to Texas, where hail is actually very common with thunderstorms. Let's see here. Katie says Veda, right? I hope I'm saying that right, wants to know if it can rain and hail at the same time. Absolutely, we can get rain and hail at the same time. In fact, that's usually how it happens. Usually the hail and the rain don't separate. They happen together within the same area of the thunderstorm. All right, so let's see here. Any other questions? Let's see here. Lucas wants to know, what is the record for the biggest hailstone? Well, I anticipated somebody would ask that question. The world's record for the biggest hailstone is from July 23rd, 2010, from Vivian, South Dakota. 8 inches wide. So that's like 2 softballs put together. Just shy of 2 pounds on one hailstone. Can you imagine that coming down and hitting something in your yard? And the thing is that this hailstone that was 8 inches across may have possibly been bigger, because the guy who found it in Vivian, South Dakota, again, this is July 23rd, 2010, he found it after it was sitting in his yard for a little while. So it probably melted from its original size. And he and meteorologists estimate that it may have been anywhere from 10 to 11 inches wide. 12 inches is a foot. So almost as wide as a foot. So here is a ruler. Can you imagine a hailstone almost this wide? So the hailstone was at least 8 inches. So that's from this finger to this finger. It may have been 10 to 11 inches wide before it melted a little bit in this guy's backyard. But of course they can't prove it, because it happened. They found it after it had melted a little bit. So yeah, it's pretty amazing. In fact, speaking of hail sizes, I want to advance over to the next graphic here if I can get the computer to do that. All right, so look at that. These are different hail sizes that meteorologists use. The smallest being pea-sized, the largest being softball. So softball-sized hail is 4 inches. Pea-sized hail is 1/4 of an inch. Now, usually, once hail gets to be an inch in diameter, that triggers a severe thunderstorm warning. Many years ago, the severe thunderstorm warning was triggered for 3/4 of an inch diameter hail. Once it got up to about dime penny size. And usually when hail is about 3/4 of an inch to an inch, it can do damage to crops, like agricultural areas. But for most people in their personal property, once hail gets to be an inch in diameter or wider, that's when it's really doing most of its damage. So again, the hailstone goes up and down inside the cloud. The hailstone collides with supercool water droplets or just regular old water droplets, and it helps it to grow. And then once the hail is too heavy for the updraft to keep it up, it falls to earth just like that. Look at all those hailstones bouncing in the yard. I remember one time I was storm chasing in Illinois. Gosh, I was in college, and we saw baked potato-sized hail, and we were chasing a tornado, so we didn't stick around very long. But I'm not exactly sure how big that baked potato-sized hail was. I want to say it was probably in the ballpark of 2 to 2.5 inches, so that was probably approaching tennis ball-sized hail. All right, so let's go back to some of the questions here, if I can find some. Amanda wants to know, when you say hail falls when it is heavy, how does small hail fall? When the updraft can't keep the little hailstones up, they will also fall just with the force of gravity down. Usually, the stronger the updraft up into the thunderstorm, the bigger the hail that it can support. A weaker updraft is not going to keep these big hailstones alive. So usually the small hailstones will fall to earth because of the weaker updraft or rising current of air. So let's see here. Rebecca Roz, where is it most common to hail? I would say in areas where you get thunderstorms commonly and areas that are colder climates. Usually on the lee side or east side of the Rockies, you tend to get a lot of hail storms. Wyoming, Colorado, but they can occur farther south down into Oklahoma and Texas panhandles. We get hail in Wisconsin. I would say that we get a moderate amount. We probably get more hail compared to folks in Florida. Florida gets a lot of thunderstorms each year, but they tend to have a warmer climate. They probably have fewer hail storms and more in the way of lightning in comparison. All right, so let's see here. Let's see here. Jennifer wants to know, how big is an average hailstone? I would say an average one is probably about 1/2 inch. You're probably looking at about just shy of dime size. Something less than that is probably about close to average as far as all hailstones. All right. So yes. All right. Let's see here. Annie says that her kids, Jocelyn, Connie, and West Appear, they're 9 and 7. They want to know, how do you know that hail is coming? Well, other than a meteorologist telling you when they're tracking the radar, if you're looking at a thunderstorm, you see a green sky, that is usually a telltale sign that hail is coming. When sunlight comes in at a very low angle and it hits the hail is, made of ice, and it's almost like a crystal. It tends to bend or refract the light all across the sky, and the green wavelength is the one that usually gets projected on top of the clouds. A lot of times people inside a thunderstorm say a green sky means a tornado. Nope, that's not true. A green sky usually means that you're looking at hail, and hail is coming soon. Okay, so let's move on from hail, and let's talk about lightning. Lightning zips across the sky, a shocking experience. There's lots to know about lightning. All right, so what happens is this. In a thunderstorm, like we talked about last week, warm air rises to produce the storm clouds. Now, inside a thunderstorm, it is chaos. If we had a classroom with like 100 kindergartners, and if I just yelled, "Run!" they would all run in different directions, right? And they probably would be bumping into each other. Think of it this way. Hailstones, raindrops, supercooled raindrops. are flying around inside the cumulonimbus cloud, the thunderstorm cloud, and they are colliding with each other. Hailstones are banging into each other. Raindrops are clashing into each other. Kids, take your hands, stretch them out, wiggle your fingers. Okay, now take your hands, put them together. All right? Now rub. Rub your hands together. What do you feel? What do you feel in there? Your hands are probably already dry enough from all the hand sanitizer and washing your hands. But you should feel some heat, right? You're feeling friction. Friction. The heat from the friction. So what happens is, because of all those collisions, the friction, positive and negative charges get pulled apart. And I always do that. I hit the wrong button. Go back. All right, that's the right button. So what happens is that these collisions between, hailstone and hailstone, or raindrop versus raindrop, or even the two of them mixed, they cause positive and negative charges to build inside the cloud from all the collisions, the friction. Now, this is the part where it gets a little bit tricky. This is the part where it's not 100% fully understood by the weather community. There is actually a little bit of debate on how these charges all get pulled apart. So a lot of meteorologists will subscribe to the fact that the supercooled water droplets are lighter, and they have a tendency to rise up with the lighter positive charges. Because of that, the positive charges float towards the top of the cumulonimbus cloud, the thunderstorm cloud. Meanwhile, some of the little bits of ice or graupel that have a tendency to drop because they're a little bit heavier, they tend to sink in the downdraft, and they tend to collect towards the bottom of the clouds. The negative charges are a little bit lighter, or heavier rather, and they tend to fall down with the downdraft and some of the pieces of ice, and so they collect towards the bottom of the cumulonimbus cloud. So it's almost like a sandwich. At the top of the thunderstorm, you've got positive charges. In the lower parts of the cloud, you have negative charges, and at the very bottom, on the Earth's surface where we stand, right in here, that's where we have more positive charges building. So it's positive, negative, positive again. And so we pull these charges apart. And for a while, the atmosphere acts like a good insulator. It's preventing those charges from coming back together again. But as the charges build, the atmosphere can't do that forever. And so the atmosphere is trying to receive, or trying to find, balance. It's trying to balance out the electrical charges in our atmosphere. So what will happen is energy from the negative charge at the bottom of the cumulonimbus cloud will try to find a positive charge. Now, in this situation I'm showing you here on the graphic, energy from the negative charge is actually going up into the top of the thunderstorm cloud and finding the positive charge. This is what we call an intra-cloud lightning flash. There's actually a few types of lightning flashes: intra-cloud, cloud to cloud, and cloud to ground. Cloud to ground strikes are the ones that are obviously most concerning for us. Now, in that situation, the lightning is actually traveling up to the top of the thunderstorm cloud. Here's another situation. We can get lightning that actually strikes from the top of the cumulonimbus cloud, the anvil, down towards the ground. Maybe there's some negative charges there, although most of the ground charges are positive. If we get any positive strikes from the top of the anvil, those can be really deadly. And I say that because they often tend to occur away from the rain and away from the hail. They tend to strike far away from underneath the storm. We often call these positive strokes from the top of the anvil, we often call them a bolt from the blue, because they often strike far from the thunderstorm itself. They can travel 10 to 12 miles away from the actual thunderstorm. So you can have blue sky overhead, a thunderstorm behind you, and all of a sudden lightning strikes 10 to as much as 12 miles away from the actual thunderstorm. All right, so let me go back. I didn't answer questions for quite a while here. Nancy Kruger Lane, age 7, wants to know if lightning can tear up your house. Absolutely. Lightning can cause fires. Lightning can destroy pieces of your house. Years ago, I interviewed a man who was struck by lightning in his own living room. This was back when I worked in Kansas before I came to WBAY. And he actually had a lightning rod attached to his home, and it was not properly installed. So the lightning actually came inside his living room, and it tore out a huge hole in the wall and actually hit him and kind of threw him down the hallway. So, but usually when you're inside, you're definitely safer. Let's see here. Stephanie wants to know, actually, Stephanie, her daughter Bailey is asking, how long can a strike of lightning be from the sky to the ground? The actual lightning bolt on average is probably about 2 to 3 miles. Could be longer, could be shorter, but a lightning bolt averages about 2 to 3, maybe up to 4 miles long. And yet, even though it's about 3 miles long, give or take, it only lasts about a quarter of a second. And it actually consists of about 3 or 4 lightning strikes inside. So there's going to be like a 1, 2, 3, 4, like as the lightning goes up and down from the cloud to the ground. And all of that is only happening in just a quarter of a second. And that lightning bolt itself is about 2 to 3 miles. So it's amazing how fast it is occurring as the electricity is channeling through the bolt itself. All right, I'll get back to some more questions in just a second. So lightning can strike many miles away from a thunderstorm. As I told you, it could be 10 to 12 miles away from the actual thunderstorm itself. So when thunder roars, go indoors. This is something that meteorologists say. We say it on TV. It is part of a public safety awareness program from the National Weather Service and NOAA. We want people to take it seriously that if you hear thunder, you are close enough where you can be hit by lightning. And, not a lot of people, get hit by lightning. I mean, the odds of you being hit by lightning are about 1 in 3,000. And that's not really great odds, but somebody can get hurt, somebody can get injured. And so if you hear thunder, you want to make sure you get inside as fast as you can. A little homework for parents with kids, not today because we don't have any thunderstorms, but in the future, if you see lightning, what you want to do with your kid is to start counting. So we get a lightning flash, start counting. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, boom. For every 5 Mississippis, that lightning strike is 1 mile away from you. Because remember, the speed of light is a lot faster than the speed of sound. So you're going to see the lightning before you hear the thunder. The thunder is being created by the intense heat of the lightning and the shock wave of the air expanding out, because the air all of a sudden gets really hot, it's forced to expand out, and you hear that expansion of air as thunder. So for every 5 Mississippis that you count, lightning is 1 mile away. So if you count to 10, well, 5 times 2 equals 10, then lightning is 2 miles away. So every 5 Mississippis, 1 mile away. For every 3 Mississippis, lightning is a kilometer away for those who like the metric system. Let's see here. Lori has a son named James who wants to know what heat lightning is. That is a great question. Heat lightning is weather slang. It really has nothing to do with heat. I mean, all lightning bolts are hot. All lightning bolts are about 50,000 degrees Fahrenheit or more, and that is hotter than the surface of the sun. Not hotter than the core of the sun, by the way. The core of the sun is about 27 million degrees Fahrenheit. But anyway, heat lightning really doesn't have to do anything with heat. A lot of people call it heat lightning because you tend to see it during a summer evening and it's warm outside and you see a flicker of light in the distance. Oh, heat lightning. But really, heat lightning is just lightning that's far enough away from you where you can see the flash from the lightning, but it's not so close enough to you where you hear the thunder. So a thunderstorm is far enough away where you see the lightning, but it's not close enough where you hear the thunder. So people they just associate it with the balmy temperatures of the evening, but really it has nothing to do with the summer heat. It's just that you see the lightning, but it's not close enough where you can hear the thunder. So that's weather slang. It's not really a real term, but people say it all the time. So anyway, that's common. All right, I just mentioned this fact, and hopefully this illustrates it here. So lightning is anywhere from about 50,000 degrees Fahrenheit to about 54,000 degrees Fahrenheit. That is hotter than the surface of the sun. And, when thunder roars, go indoors. That's something that you don't want to strike you. Obviously, it can burn you, but it can do even more serious damage internally. And so it's very important that we take that very, very seriously. All right, so let's see here. Cole, can lightning start fires? Absolutely, especially in areas where we have forested areas that are dry. Wildfires are sparked by lightning, and they can be very, very dangerous. Tricia, can two lightning bolts hit each other? That's from, I'm guessing, her son, Sam. Yes. In fact, multiple lightning bolts can happen at the same exact time. What often happens is that we will have what is called a step leader. So you know what I'm going to do? I'm going to try to back up. Pardon me here as I'm kind of playing inaudible here. Okay, so here's our thunderstorm. And what will often happen is we'll have what's called a step leader. It's kind of like a zigzaggy charge of electricity that's coming from the bottom of the thunderstorm where all those negative charges are. And as it comes down to the ground, we'll often have what are called streamers. Streamers are negative charges that are actually growing up, trying to find the negative charge. So the positive streamers come up, the negative charge comes down, and what happens is the negative charge usually picks one of those streamers. And then all of a sudden, zap, 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 and it happens really fast. So you can have multiple bolts and multiple streamers all happening instantaneously with that lightning bolt, that lightning flash. I hope I explained that okay. It's complicated, but I'm doing my best here. We've got elementary and middle school kids here. So let's see here. Kari wants to know, can lightning strike upwards? Absolutely, yes. Lightning can strike upwards. Lightning can strike upwards. Lightning can strike downwards. We're just trying to complete a circuit from the negative charges to the positive charges. And any way that circuit is completed, whether it goes down or up, then we can have that lightning strike. And a lot of times we have different types of lightning that are described. Sometimes you hear what's called forked lightning. That's basically kind of like lots of ziggy-zaggy lightning going in different directions, forked lightning. Sometimes you hear of a term called sheet lightning. Sheet lightning is not where you really have a very visible bolt, but the whole kind of cloud kind of lights up. It just kind of covers the whole sky. You really don't see it one bolt, but it's just kind of a flash that kind of covers the entire cloud. There's even a phenomenon called ball lightning. Ball lightning is something that meteorologists and scientists really don't understand. There have been stories where lightning has hit the ground and it actually takes on kind of like a sphere, a ball shape, and starts rolling. And there have been stories where it's rolled past people and into homes, and it's really kind of a strange phenomenon. Honestly, I don't know enough about it, and meteorologists and scientists don't know enough about it either. It's definitely very interesting. So lightning has a lot of power to it. I actually took down some stats here. A bolt of lightning has 100 million volts. Voltage is the electric pressure through a circuit. 100 million volts of electricity. And also about lightning is that there's a very high amount of amperage to it, anywhere from 5,000 to 20,000 amps. Amperage is the overall energy of the electrical discharge of the lightning. So wouldn't it be amazing if we could harness lightning and use that power? If you were able to harness the power of lightning, just one lightning bolt, you could probably power a 100-watt light bulb for probably about 3 months. The thing is we can't harness that kind of power. If we could, it'd be amazing, but it's just too fast, it's too quick, and we just can't grab it like that. But obviously, it is a risk to our personal safety. Lightning and all electrical currents can travel easily through water and metal. This is why you really shouldn't shower during a thunderstorm. Even when you're underneath the faucet or wherever it is you're taking a bath or a shower, in the water coming down, water is a good conductor. It can pull the electricity through. And inside the water, when you take a shower, are very microscopic little bits of metal that are actually probably in the water as it's streaming down on you as you lather up for a shampoo or for a soap. And so that's why you can get hit with electricity if you're taking a shower. This is why boaters need to get off of the water if there's thunderstorms nearby. We hope that people who are out fishing and boating on Lake Michigan or Lake Winnebago or wherever, if you know there's stormy weather, you want to make sure you get to port as soon as possible. So safety tip, always stay away from water, wet items, and metal objects such as fences and poles anytime lightning is present. And the other thing, too, is that lightning has a tendency to strike the tallest object in an open space. Not always, but often. Whatever helps to complete that circuit from the negative charge to the positive charges, whatever is the most easiest way to complete that circuit is probably how the lightning strike is going to happen. So tall objects allow for that circuit to be completed a lot easier. So this is why buildings and telephone poles and people who are on golf courses with a golf club, they have a higher probability of being struck by lightning as the people who are low to the ground or better yet inside. So safety tip, excuse me, avoid open fields, the tops of hills, ridges, trees, and other tall objects. If you are caught in a thunderstorm, you don't want to be underneath a tree. That is a dangerous place to be. You want to get inside. Let's just say you're out in the middle of nowhere. It's best to just lay flat on your stomach. This is assuming that you have no place to go, no shelter, no buildings, no home. You're out in the middle of nowhere. It's best to lay flat and minimize being high up and being easier to complete that circuit where the electrical charge comes through, positive and negative charges. All right, so let's see here. Chelsea, my son Colin wants to know if lightning can spin like a tornado. I am not aware of lightning spinning. And because lightning is so fast, I don't know if it actually even does spin. Let me also do something else for you kids at home. Okay, so here's an activity for you guys. Okay, so lightning travels about 3 miles in the thunderstorm to the ground. Lightning. It is 50,000 degrees Fahrenheit or hotter on the surface of the sun. Who out there, kiddos, can tell me or show me with your fingers or your hands or your arms how wide a lightning bolt is? How wide is a lightning bolt? Remember, over 50,000 degrees Fahrenheit. It's got 3 miles zipping through the sky and 100 million volts of electricity. How wide is a lightning bolt? Let's see. Anybody? All right. A lightning bolt is as wide as 2 pencils. 2 pencils. That is about how wide a lightning bolt is. 2 pencils side by side is about how wide a lightning bolt is. So if lightning were to strike this computer, there would be, right there, that's about as wide as the hole in the computer, assuming that it didn't blow up into a million pieces and catch fire. All right. Let's see. Zoe from Gracie, can lightning hit a car? It sure can. The good news is that if you are inside a car, due to what's called the Faraday cage principle, lightning tends to go around the automobile. So it goes around the automobile, and if you, assuming that your windows are up and you are fully inside the car, you should be safe inside as the lightning hits the metal and goes around the body of the automobile. So cars, yes, they can get hit by lightning, but you should be safe inside a car. So if you are at this football field that I'm showing you here, and if there was a thunderstorm, a good place to go would be not under the bleachers and not in the field, but back to the parking lot to go inside the cars and wait out the storm. And as a coach for soccer, I've had that experience of quite a few times. So yes, parents, that's something you should always keep in mind of anytime there's thunderstorms in the forecast for your kids' games, assuming that they are able to get outside and play some sports sometime soon. Okay, so some of you may be wondering, okay, where are lightning strikes and unfortunately fatalities most common? Well, the map you're going to see here actually ranks in groups of 10 the hot spots, so to speak, where lightning strikes are the most common. Florida gets the most. Florida gets the most within the United States. Worldwide, there are 2 hot spots where lightning is most common. Central Africa, lots of tropical thunderstorms there. Actually, incidentally, it's those thunderstorms as they make their way west out into the Atlantic. If there's warm enough ocean water, they can spin up into hurricanes. But it's in Central Africa and the tropical regions, they have lots and lots of thunderstorms, lots and lots of lightning strikes. But just as lightning is common there in Central Africa, there are portions of Venezuela right along the ocean there, the Atlantic Ocean. They have lots of tremendous thunderstorms and lots of lightning. So those are probably the 2 biggest hotbeds for lightning on our planet. In the United States, Florida ranks as number 1, and you can see in the top 10, we got Texas, Arkansas, Louisiana, Tennessee, North Carolina, the Mid-Atlantic, Colorado. Is Wisconsin in the next group? No, not quite yet. In the teens, you got Oklahoma, Missouri, Illinois, Michigan, even Upper Michigan tends to have more lightning fatalities than Wisconsin. Wisconsin is in the 20s range, so depending on year to year, usually between 21 and 30, so it's kind of in the middle of our 50 states. But lightning can occur in all 50 states, although it's extremely rare in Alaska, and you tend to find fewer lightning strikes, especially in colder climates like up in the northern Rockies, and also along the Pacific coast. There are fewer thunderstorms with lightning strikes there. It seems like the states that have the biggest threat for lightning strikes, injuries, and fatalities, the Deep South, and interestingly enough, portions of the Mid-Atlantic as well. All right, so let's see here. Going back here. Any other questions? Let's see here. Rhea from her son Nate. Are you safe on your boat in a storm that pops up? Not really. You really should be bringing that boat back to shore as soon as possible. This is why I really think it's a great idea for boaters to bring along a NOAA weather radio. That way you can listen to the forecasts. Or if you've got your smartphone, you can have our app, the WBAY First Alert Weather app. I know I'm doing a little bit of promotion here inside our school visit, but if you have the app, you can track the storms, and that comes in handy if you're out in a boat. But hypothetically speaking, let's just say you are stuck in a boat, you cannot get back to shore, but a thunderstorm hits, then you really have no other choice than to ride it out, and it's best to lay flat in the boat in a worst case scenario. So that's better than nothing. So, all right. Amber wants to know, can planes get hit by lightning? And they sure can. On rare occasion, lightning can damage a plane, but usually lightning tends to go around the metal of the aircraft. And I think planes nowadays, they have some certain measures to kind of help protect them from getting a lot of damage from lightning. Let's see here. Dylan wanted to know, what is the heaviest that hail can be? We had that in the very beginning of our session here. The largest hailstone in Vivian, South Dakota weighed just shy of 2 pounds. So that is a very big hailstone. All right. Let's continue on here. Actually, we're right back to the beginning. We are right back to the beginning of all the different graphics here. All right, so let's see here. Any last questions here before we wrap this thing up? Michaela wants to know, how many lightning bolts are there in a thunderstorm? Well, it varies, but let me give you kind of an example here. So, some thunderstorms have more lightning than others, but about 100 lightning bolts are striking the Earth's surface every second. Let me say that again. 100 lightning bolts are hitting the Earth every second. 100, 200, 300, 400, 500. So just in 5 seconds, about 500 lightning bolts have hit our planet. That's a crazy number of lightning bolts to think. And that's about 8 million lightning strikes per day and about 3 billion per year. Now, how much lightning comes out of one thunderstorm? It really varies. This time of year, we tend to see storms that have a lower lightning count. But if we have a severe thunderstorm that passes overhead, there can be hundreds, if not even thousands, of lightning strikes. It really just, it depends on the situation. All right. Byron wants to know, can lightning strike a flashlight? Yes, lightning can hit whatever it wants as long as that electrical connection from the positive, negative charge gets completed. All right. And we'll make this the last question here because I do have to wrap up and do Action 2 News at noon. Courtney, her son William asked if hurricanes have lightning. Oh yes, they absolutely do. Hurricanes are just organized groups of thunderstorms that are swirling around an eye, and yes, they are definitely lightning producers. All right, so again, thanks for stopping by Weather School. I tried to answer as many questions as I could. I apologize I couldn't get to them all. Moms and dads, if you are having a little kid at home who's excited about the weather and they want to learn more, feel free to really dive into Google and dive onto the web and answer questions. I remember I got interested in weather in between 2nd and 3rd grade, and it was because of lightning. I lived at home with my parents. My parents didn't live in Wisconsin. They lived in New Jersey. They still do. I grew up in a house 40 minutes outside of New York City, and I remember a summer in between my 2nd and 3rd grade, I was sitting at my parents' screened-in porch. My parents had a porch screened in, and we had a little black and white TV, and I would watch baseball games out there with my dad. And I remember one evening, it was just quiet and balmy. It was just great, great weather. And I remember watching in the distance these flashes of lightning getting closer and closer and closer. And you could hear the thunder rumbling, got louder and louder, and all of a sudden it just poured on top of my house. And I was just so amazed and transfixed by the whole thing. My dad was like, we probably should go inside. And I was just like, can I stay out here? And it was that moment I was just like, I want to learn more about thunderstorms and lightning and weather. And it all started from there. And in a way, it was like a little seed was planted here. A little seed was planted here. And through education, through reading books, that fed the seed. And the seed grew into something bigger. Not a flower, not a tree, but it grew into a meteorologist. Now I'm 44 years old, and I've got my own kids and my own house. I don't have a screened-in porch, though. But you know what? If your kids have that seed, and it doesn't have to be weather, it could be anything. If there's something that they're really that passionate about, make sure that they are reading books, that they are reading stories, and getting their hands on fiction and nonfiction about all the things that it gets them curious, gets them interested and excited. If it's weather, awesome. If it's not, that's okay. We can't all grow up to be meteorologists. If we did, it'd be pretty boring anyway. But whatever it is, keep giving the kids the books. Kids, keep reading about what you like to learn about. Let that seed in here grow into something beautiful. You don't feed this with dirt. You don't feed this with sunlight or water. You feed this and this with education. So keep on it. I know it's hard right now. We're not able to actually physically get to school, but don't stop. Don't let the video games take over your life. Take a break. Do your schoolwork. Keep on top of it. Feed the seeds that are here. And I hope to see you guys next Monday. We will have another weather school topic to be determined. I'm going to let you guys go. Have a great Monday. Thanks for stopping by. Take care. Stay safe. Stay healthy. Bye-bye.